No worries.
All right. So, good morning, everybody. Welcome to TST meeting. Today, what we have on the agenda is a presentation from about their use cases and various technical proposals. And so, I'm going to thanks, by the way, for sending the um, information up ahead of time. But I'm going to give you control so that you have chance to change the slides at your own pace. That's okay.
Okay.
So hopefully you received the screen invitation.
Yeah.
Okay, you can see a screen.
Okay, so I will start right away from the presentation.
Great.
So basically, this is the name we have given to our SDN controller, which is basically focused towards the need of the broadcasters. So we name it broad control, and we will shortly discuss about various points, as you can see on the slide. A brief about transition of SDI over IP, broad control and what are the existing solutions in this domain, feature priority one, which we basically focus to deliver in coming future. And there are some priority two features also, which we plan later after the priority one features has been achieved. I will tell something about the equipments available in Stordis lab in Germany, and I have some brief or approximation of the timelines to achieve the features we will. So let's start with the short introduction about what is the transition of SDI over IP. Basically, this is the whole key driving factor behind this controller idea or so. So far in the broadcasting industry, how the media is being transported is in the form of byte streams over the coaxial cables. So this inherently comes with lots of limitations. One of the most prominent limitation is that it is limited because one stream or one connection or one coaxial cable is limited to carry only one stream. That connection, that stream cannot be shared among various signals. So this is why all the broadcasters are willing to move towards IP these days. But at the moment, nobody is using at full. Most of the people, most of the broadcasters have the hybrid solutions or are in the experimental phases. So as you can see, there are various benefits or drawbacks which are existing in the SDI, and why it is beneficial to move towards IP. One is the 4K video. The coax cables, which I was speaking about, is quite limited in capabilities to carry the ultra HD signals. I mean, after 5 meters or so, you need to have the repeaters to carry the signal further. Another is the scale and flexibility. For sure, each stream is dedicated to carry one signal, and the port, the broadcasters use some special kind of switches also called metric switches. So each port is dedicated to only one signal broadcasting. Uh, because of these limitations, IP solutions becomes cost effective automatically. And another is if you have a production studio here, for example, your news is being broadcasted, so your control room at the moment will have to be there. But it can be decoupled if you are moving towards IP. Another is um, an obvious reason. It When you move towards IP, it gives you the capability to share the resources, like a link, 100 gig links can easily be shared easily to carry various signals coming from different cameras or different studios. And also, this is the next thing. Virtualization is quite a futuristic thing. Here, media control functions can virtually be hosted in the cloud on certain kind of special hardware. I mean, basically high-end hardwares. This is a futuristic approach I have mentioned here. Another, I mean, this is like controlling various production studios from the single place. So SDN controller fits pretty well in this scenario. Of course, when you have the IP infrastructure. So this is, I mean, quite brief about SDI to IP. So the broad control, the project we have, the idea at the moment, and the existing solutions. First of all, there is no open source project which actually addresses these problems at the moment. There are a few which I have mentioned here. BFE's SilkNet. This is a proprietary solution, and another is Nevion's a video path orchestrator. Both of these solutions, first of all, are proprietary, not open sources, and are very much bound to a special kind of hardware. So they do SDN, but yeah.
Yeah, when you say Nivian is bound to special hardware, is this their own hardware or is it just a specific set of switches that it's bound to? Could you explain that a little bit?
This is their own hardware and apparently have more than one ASICs.
There's a dual ASIC switch they have because the Broadcom ASIC is limited to do or can't do netting and multicast at the same time. So what they do is they use these dual ASICs to do them in the same process, same.
Right.
Yeah.
So
do they control that hardware via an open protocol or is it a proprietary protocol?
I don't have that much in-depth knowledge about that.
Okay, thank you.
I know they have some kind of SDM. I think they are ODL based, if I'm not mistaken, but I don't know how they control the hardware.
Yeah, I mean ODL could mean still proprietary protocol from the ODL controller to their hardware.
Yeah.
Okay.
Yeah.
Thank you.
So yeah, so the main USP of our use case is that it will be an open source and focused towards this open networking technologies like, I mean, the white box, which is using your own NOSes, and we do think about use of P4 also. That we will discuss in the coming slides. So this is the priority one, feature number one, that is fault tolerance and robustness of the streams. When I say streams, at the moment in ONOS, we can correlate it with the intents, and literally this means a link. So in our setup, what we do is we have some host devices, which are basically SDI to IP and IP to SDI converters. So a functionality of intents is already there, but it is not fitting as per our use cases. Like if you set a intent from host A to host B, and it is going over some link, and in that link goes down, then ONOS starts deploying new flow rules and new intents. During this deployment, a lots of time is lost, a lots of packets has been dropped. So the idea is, if I can modify or update the intent framework in ONOS in such a way that if users say, okay, I need 3 backup paths for these particular streams, so it beforehand goes and installs 3 or 4 intents. And of course, there should be some intelligence so that all the intents are not flooded with the same traffic. So deploy these intents in such a way that the flow rules have some unique matching criteria, which doesn't match with any networking packet or anything at the moment in the network. But when active intent goes down, then we do some packet processing to update the packet to literally match the matching criteria which are present in the backup intents. So this is.
Do you see these intents being completely separate paths? I mean, or somewhere they're going to unify and join anyway, right? There's going to be some common links between these intents, or they're going to be completely separate paths?
Ideally not. Ideally there will be separate paths, so that we can guarantee when one part fails, the other will always work.
Okay. I
Mm,
mean,
but and
that means there's some also, it's not just SDN build out here then, right? It is some physical network requirements beyond this to enable having those separate physical links going, redundant links.
Yes, there might be some requirement on the hardware as well.
yes, I mean, first of all, there will be some redundant links. I mean, apart from one link, there is a possibility of another path as well. But what I explained here is the modification we will require to do in ONOS. I mean, at the moment, ONOS doesn't deploy
Yep.
or right. It's a passive deployment of the intents. Once you receive the failure, then it just starts deploying the new link. Okay, and another is auto switching among the streams or intents in case of failure. Yes, obviously it should be there. HA, high availability is already supported in ONOS, so no problems with that. Lag support, link aggregation is also required, which I believe it's not configurable via ONOS, but if you configure a lag in the switch, it can be displayed as a single logical port, I suppose, but it's not configurable as per my knowledge at the moment. So this we will have to implement. So feature number two, this is a kind of traffic engineering, and you can actually assume it to be a sub feature of the feature number one, where we spoke about deploying multiple backup intents beforehand, but there should be some additional intelligence in the framework so that controller should be able to identify the factors like latency of a particular link or intent, what is the latency, and bandwidth available in real time over that link. So purpose of knowing these things is in the broadcasting network, there are different kind of traffic flowing simultaneously. It may be for logging, it may be for static playback, it may be a live stream, but user not always want a single factor to be perfect for a particular traffic type. For example, if it's a live stream, a user is very much interested to choose a path which have the minimum latency, of course with the bandwidth required to carry that signal, but the priority is the latency. In case of passive backplay, user doesn't care about the latency, it's more or less about the bandwidth. So this kind of intelligence, I mean, choosing the intents based on the traffic type in case of failure or like that is
So are you talking
required.
about both bandwidth and latency kind of reservations or
Yes,
limit? Okay. All right.
yes. Okay, this is another very important feature which we would like to have, and we have done some research also. Uh, this is the seamless and glitchless switching. I mean, if I'll give you a brief about it, basically, image is basically whatever you see on the television or so. Whatever is moving, basically that is not moving. It is these are the static pictures which moving fast per second. So these pictures are called frames. So the what do we mean by switching is in this example you see there are two cameras. You can assume them to be placed in somewhere in stadium where a football match is being played, and let's say output display 1 and 2. Output display 1 is receiving the signal from the camera 1 and the another is receiving signal from the camera 2. At some point of time you may require to switch the views like this. So this we cannot do right away in the stream. For to do that glitchless, what do I mean by glitchless is, if you see on the right side, this image is showing you a scenario where a part of the frame has been taken from a packet, which is RTP, and rest of the part has been taken from another RTP packet. So this image is a combination of two images, which causes a glitch while you see it on the screen. So to achieve a glitchless switching, we need to do some packet processing, and we actually have an idea to do it in the switch using P4. Basically, these frames are made up of RTP packets. So you'll have to know when the end of the frame has been achieved. So at this point, you can switch the stream. So the new screen, the new basically image will be from the new source altogether. There will not be any mix and match.
Okay.
So, but to achieve, yeah.
A couple questions based on my ignorance more than anything else. One, is there any? This seems to all be unicast streams, not multicast streams. Is there a play for multicast here?
No, this will be multicast.
Okay. And the other question is, my knowledge of video compression and video transmission algorithms. Unless you're transmitting full frames, each frame fully, you're doing some compression and transmitting delta from one frame to another. So in other words, frame at T0 or T1 is really just a delta from frame at T0. So if there's not much image change, the frame could be very small. It can be compressed. Now, when you're doing a switch like you do here, you can't just go from you all of a sudden have to start transmitting the full frame again because you don't have the base frame, the key frame that you're doing the delta frame off of anymore. So how do you see that being compensated for if you're doing compression?
Compression, we are not doing. All the signals
At the moment, we have not considered compressed playout. So we are considering playing out basically of uncompressed signals at the moment. So in uncompressed, you will have you're transmitting the whole frame. This would be doable. Uncompressed, we have not thought about that scenario at the moment. I would
basically before coming up with this project idea, we spoke to several of our customers and partners, and I think nobody of them was speaking about the processing of compressed signals.
Mostly they're looking at uncompressed signals. But of course, your point is very valid because most of the playout at the moment is also is compressed. So we need to cross that bridge when we get there.
If you're using uncompressed video, raw video, the bandwidth requirements as well as latency impact skyrockets, right?
Yeah, that's true.
All right, thank you.
Okay, so this is all about seamless switching. This packet processing we prefer it to do in P4 in our Tofino-based switches. QoS and metering support, that is again an important thing. Almost every customer would like to have it in the solution, and luckily we have enough support in ONOS in that regard. That is not exposed via REST interface at the moment, but we have done the coding to expose it on the REST. So we don't do much about it. Forwarding traffic to a multicast group. This is a kind of plug and play feature where you can suppose like you have some source which is generating video, and on the other hand you have some hosts, basically IP to SDI converters, which are receiving these signals. Suddenly you have more requirement where you need to plug in more hosts, and you want that host also to automatically start receiving the same signal which other are receiving on the basis of a particular multicast group. Means if a newly plugged in host is also in a particular multicast group, it should start receiving the signal which is intended to that multicast group automatically. So this is a kind of learning feature for controller, where the controller should maintain a state inside it of the port to a multicast group. I mean, it should always know that, okay, on this port, this multicast group is listening, and on this port, this multicast group is sending the data, and as soon as a new host comes in, automatically deploy a rule which actually forwards all the traffic to that particular port. So
So
this
is
is
my understanding correct? You expect to do unicast traffic to a certain point in the network, and then at that point, turn the unicast traffic to multicast?
yes.
Um,
This
Kind
is
of, yes. So basically, what happens is, I mean, we are looking at the moment OpenFlow, right? We're talking about OpenFlow.
yes.
So we are going to be doing mainly Unicast itself, even though the traffic.
Yeah, another way to achieve this could be if we totally go with the IGMP. We run our switch in L2, L3 mode, and IGMP can take care of it. But we don't want to do it.
Yeah.
As soon as we do it in OpenFlow, it's a unicast. But you want to make the system intelligent that it does multicast in some time also.
So basically,
why don't you want to use IGMP here?
There has been certain performance issues.
There's lots of performance issues with IGMP when you're switching between two different. So the receiver is switching from one listening to one multicast group to the other. There is a lot of delay in IGMP joins being sent, and basically first it needs to leave the previous group, or rather, if it does, there are two main methods which the broadcasters look at. One is the make before break. That means you join the second multicast group and you do some buffering on your end device and then leave that group, or you break. And the other one is break before make. That is, you leave the IGMP group and then join. There's of course lag involved in both these cases. So ideally, what we
right. So what I've seen in industry is sometimes what happens is when you change channels effectively, you begin with a unicast stream, and that unicast stream is used for a limited period of time until the multicast switch happens. And so you've got this kind of hybrid model, which says, okay, I switch channels, I go to a unicast stream for call it 15 seconds, and then after 15 seconds, that's enough time for the IGMP to settle, and then I go jump on the multicast stream.
Okay. So what our policy is that we will be completely transparent to the end device. So everything will happen in the switch transparently to the end device. So there is no buffering required. There is no delays, no nothing. This is the whole idea behind our.
Right. Yeah, but what you're saying here is IGMP doesn't work, and so we're going to implement our own version of IGMP that does work somehow.
Not really. So we're not forwarding any joins, not forwarding any leaves. We just want to maintain the state in the controller. So basically a table saying this sender connected at switch port blah is sending on this multicast group, and these are the receivers listening to these groups.
Yeah, but that's IGMP, right? You're keeping channel state.
Yes, exactly. Instead of doing it in the switch, we maintain the state in the controller and just forward it using Unicast, or basically OpenFlow. This is the whole idea.
Right, but if I had an IGMP capable switch or a router, it would be happening in the router too, right?
Yes.
You're doing the same thing, but you're saying you're going to be able to do it such that you don't have the latency change when you switch channels. Yes. That's what I'm hearing. Okay, I don't know. That's what I'm hearing anyway.
Yeah. Exactly what you want to hear. Yeah.
Okay.
Yeah, you can call it an improved version of your IGMP.
Yes. Just a comment on this. Currently, the ONOS Multicast subsystem in Trellis with Trellis applications and segment routing does support, I would say, a major subset of what you are looking at. Because if you give a multicast command with a host ID, even if that host is not present in ONOS, the flow rules will be provisioned once that host connects.
Okay.
So let's say you have what you call here a plugged-in host, which is not currently there. But you know that his MAC address is a given MAC address. If you specify a multicast command in ONOS with that MAC address, as soon as the host gets plugged in, ONOS programs the flows through it. So the only thing is missing here is learning the multicast group of the plugged in host. But apart from that, everything else is there.
Okay.
In Trellis. Charles,
I don't know much about Trellis, but how can we bring that functionality into this controller? Are there some jars or libraries which we can call right away, or in terms of development, when it comes to development?
I would take a look at the Unicast.
I missed the question you were trying to ask me. Can you say that again?
No, I was just making sure I didn't trip on any detail.
No, I don't think so.
And on the other question, you just take a look at the Unicast application. That is the one that receives the multicast requests and handles multicast route events. Basically, what happens is that it receives a request, it stores it, and it issues an event. What then we do in segment routing is actually dealing with the request and provisioning the rules. But you can also take a look at that code if segment routing as a whole does not fit your need. But the Unicast app is the one that deals with the event of source added, sync added, and all of that.
And Trellis also has ability to do lossless transmission over link failure too, doesn't it, using the OpenFlow groups? So instead of a link from a leaf to a spine goes down, we're not losing packets as we switch to a spine. Is that accurate?
So the thing is that in the Unicast use case, we use ECMP group, as you say. We have buckets for each link, and then if the link goes down, we simply just remove that bucket, and it will just hash to the other links, right? But the thing is that so I'm not sure which switch you're looking at, but for the OFDPA, it doesn't support ECMP group for multicast. So, which means the multicast group, there's some other honest logic that need to put in to kind of pre-provision the secondary path in, in preparation for link failures, and we don't do all of that right now. So I guess, if a link fail at this moment, segment routing would detect that and reroute the traffic. But I would say there may be a glitch over there during the switchover because we didn't pre-provision, pre-allocate the backup path. But that can definitely be done in the app logic. It's just we haven't done it yet. But I don't think that's a big problem because usually you will have receiving buffer at your sync or client side, and that should hopefully eliminate the glitch by having buffer over there.
Okay. By the way, this lossless transmission, which project will contain this functionality in Trellis, or?
So, as I say, the Trellis, you'll probably still see the glitch in the network when you switch from one path to another because the current implementation didn't pre-provision that the secondary path. But I'm just saying that if you're a client having a buffer when you play the video, then that glitch shouldn't cause any problem because the buffer should just soak the thing, and then just from the user perspective or user experience, you shouldn't see any difference.
The problem we might run into is synchronization. But we can have a look at it because buffering is not good for.
Yeah, buffering. Everyone don't want to.
Exactly, buffering is not. I would say it's not the solution we are looking at. Usually, looking at higher end frames like 4K, 8K, you cannot really buffer too much. Just looking at the amount of bandwidth they consume, next to impossible to buffer those frames.
Yeah,
But yeah, we can have a look at it. We will have a look at that and figure out what we can use and what we can't.
Okay, if you're thinking about real time and you care about synchronization, then yeah, you need to have like almost lossless network. And I don't think the current implementation of Trellis can give you that, but the app can be improved fairly easily, I think, to pre-program a secondary path, and the switchover should be lossless if we have that.
Okay, I think we will look into it. Okay. Guys, I will have to shortly leave. I will join remotely soon. Yeah. Okay.
Okay, I mean, now these are some features which are priority 2. Like many customers say us, we need some functionality to configure the port, like it's speed, VLAN, trunk, bridge, etc. That is also not present at the moment, but we can have a look on this later. This is not P1. Again, the security, the access security, and device authentication, so that every device is not allowed to get discovered as an OpenFlow device or so in ONOS. Another is AMVA and MOS. If you are not aware of it, it's basically a database which can be accessed via REST, and this contains the data about which we have been speaking about, the hosts,
the end devices,
SDI to IP and IP to SDI converters. So if this can be integrated, this gives the SDN controller an additional capability to basically configure your end devices as well. But again, this is again a P2. So a brief about the Stordis test lab. We almost have every device which is required to test, to develop this SDN controller, including Profino and Broadcom-based switches. We have enough of them. SDI to IP and vice versa converters. Basically, at the moment, we are using Embryonics devices, which does the purpose. And video playbacks from Blackmagic and several others. We have cameras to generate the live streams. Synchronization signal generators, basically to sync the signals which are coming from different sources. We have these devices, packet analyzers and the PTP Grandmaster.
So yeah, the sync generators are basically an external device for synchronizing the signal. Ideally, we would want to use PTP to synchronize it directly in our switch.
So the PTP is alternative to the sync signal generators, or maybe I'm confused.
Exactly, it's an alternative. So the sync signal generator is basically an external solution where you synchronize a signal before you put it onto our switch, and PTP is ideally done as frame synchronization in the switch itself.
This sync generator is specific to these video streams or audio streams.
Exactly.
And the interfaces which it have is SDI.
Yes.
Okay.
So ideally, we would use Weinberg or one of those Tektronix or one of those PTP Grandmasters to synchronize.
Yeah, this will be an alternate.
This is the alternative. Exactly.
Sorry, is your PTP server internal or external to the switch?
At the moment, we don't have any PTP boundary clock implementation. So we do have a transparent clock implementation in few of our switches or few of our PK8 based switches. We do have PTP transparent clock implemented already, and the Grandmaster is of course an external device.
Okay.
Okay, so this is about the test lab, and it's a rough estimate for the P1 features. So I could guess roughly around 1 man year to implement all these priority 1 features. Might be plus or minus for sure. Yeah, so this is pretty much of it. So guys, any further questions you can come up with?
Well, this is really interesting.
Yeah.
A surprising area for ONOS deployment, but I guess when I think about it, I guess it shouldn't be surprising, but it's
Mm-hmm.
very interesting.
Mm-hmm.
So
Yeah.
I have no question, but maybe a comment. So as Andrea already mentioned that most of the feature you need, except of the lossless part, is already implemented in Trellis, and then Trellis has already worked with DPS switches, and then we are also working on, as you may have known, that we are going to have a demo in ONS EU about integrating DPS switches with P4 switches. So we are also working on the multicast on the P4 switches. So I think that's most of the part is what you need already, and then what you need to do in addition is probably to figure out how to provision the backup path and make sure your traffic is lossless during a link failure or during a switchover. So I think most of the effort, I think a Trellis is probably a good start. I would suggest you start exploring that instead of doing some duplicated work, and maybe you can bring add values to Trellis by implementing the backup path and the logic over there. I think that would
Yes,
be beneficial for both of us.
for sure, we will avoid the duplicate work. We will definitely look into the Trellis further. I mean, apart from that, we see a major requirement in terms of packet processing in the switch. What kind of support, or is it already there, some support in Trellis or so?
So packet processing in switch, I think the OFDPS switches will be very limited. I think P4 is probably your
Yes.
better option right now. So
Yes.
I'm working with the other guy from ONF on a P4 integration right now, and we're going to demo that in ONS Europe. So by the time of next month, we should probably have an integration. So basically, what we plan to demo is a network with both P4 and OFDPS switches in there, and then you can do extra things like extra packet processing with the P4 switches.
But even remember, for the P4 stuff going on right now within ONOS, it's a very specific P4 program that supports very limited capabilities. So it supports or looking to support feature capability or feature compatibility with the current Trellis fabric and maybe add INT, right?
True.
So it's not a generic P4 program.
Yeah, that part, since that's P4, it can be easily extended too, right?
Easily extended a stretch, right? I mean, yeah, it can be extended because it's P4, but it also would take work both on the P4 side, the program side, as well as potentially within ONOS to take advantage of any changes you make to the P4 pipeline.
Yeah, I think what we can do is that we can do something similar to, so we have another P4 program that encapsulate and decapsulate the GTP tunnel for a mobile network. And what we do for that is that we put a GTP tunnel in front of the Trellis packet processing pipeline. So basically, you run two pipelines in the switch. You encapsulate that first and send it to the Trellis pipeline and route it. And then on the downstream side, you kind of, or on the opposite side, you do it the opposite. You decapsulate that first and then put it into, you forward it through Trellis and then decapsulate that. So I think a similar idea is already verified by the GTP pipeline. So you should be able to do something similar, that you implement your packet processing pipeline and you deal with the packet and then send it to the Trellis pipeliner. And it's like 2 stages.
Okay.
That should be possible.
Okay, one more thing, if you can suggest something around, because we do not have all the customers who would like to buy the P4 switches for this. Maybe some of them would be interested to have the regular Broadcom based OpenFlow switches. This kind of packet processing, if we want to do in OpenFlow, some of the our partners do provide the implementation of experimenters.
Yes.
But that is not yet up to our requirement. I mean, we want to process only RTP packets and want to play around with the headers. So is there any suggestions from your side? How can we achieve it in OpenFlow? Is the experimenter only way, or?
So the thing is that even if you use OpenFlow Experimenter, you need that implementation on the switch, right? But I don't know if the OFDPA software on the switch right now can meet all your packet processing requirements.
I think OFDP is very limited on that.
Yeah,
but we have switches which are based on OES. I am not sure if that is extensive enough at the moment that we can use it. So we need to have a look at that as well, ideally.
Yeah, that I don't have an answer. I don't know what those switches are, and I'm not sure if they also implement the OFDPA pipeline. If not, then you probably need to build your own pipeliner in ONOS, like a driver, to kind of talk to that device.
Yeah. Okay. This is the.
Okay. Thank you for the comments, guys. We will look into Trellis and also have a look at what we can do there. And yeah.
Yes, because but to implement experimenters, right? Some drivers will be very specific to a device.
That's exactly. That's what I mean. That's the problem I'm having as well. Because
the ONOS driver is designed to be device specific, right? The reason we have this driver level is because we want ONOS can be used with different devices, so we build drivers for each of them, right? And I think that's not a problem. The problem is that there are extra effort in order to build this driver.
Yeah. Yes, exactly.
We already have a driver for OFDPA. We already have kind of a fabric pipeline or driver for the P4 switches. That's for the Trellis. And if you need things in addition to that, you probably need to do something additional.
Yeah, understood. I think I will drop off, guys. It was nice talking to you, and
okay,
have a nice day.
Yeah, this is pretty much about it. We will definitely look into the Trellis if it seems we were looking into the wrong project so far. Who knows, as per our requirements.
Yeah, so Trellis use ONOS, so I mean, just we build application on top of ONOS, and that application already meets maybe 70 or 80% of your requirement. So just see if you can complete the rest of the 20% by extending that.
Mm-hmm.
Yeah, if yes, that would be very nice.
Yeah, sure, for sure, we will look into it. Yeah. Okay, this is if you guys have further questions, you can ask, please.
I don't have any.
Not on my side.
Okay. Waldy, do you want to mention something, or is it also okay from your side?
It's absolutely okay from my side. Question, okay, I mean, what we would need to do is, of course, look into Trellis, you know, and check all details there and see if we can add things from our side, or if it needs to be still dedicated. I mean, as far as I can hear, I mean, the use case itself is kind of good also for the TST team to go with, and could be an interesting improvement on the ONOS side as well, right? I mean, it's also not ending with the broadcast use case, but looking towards you know, other solutions, other industries, other markets. Industry 4.0, they have not the same, but also partially similar requirements. So it could be good in general, I believe.
Yeah, okay.
All right.
All right, guys. Thank you very much for joining in. And yes, we got some really important leads with this meeting. We will definitely look into the Trellis and focus on that further.
Yeah, well, it's great. I definitely would be looking forward to seeing some demonstrations or news of you guys making progress with this. I'd be,
Yes.
Please keep us informed, and don't hesitate to use the mailing list for asking questions, or it's a great resource, I think, for getting access to the overall community.
Okay. Yeah. Sure. Yeah.
All right. Well, thank you again for taking time to present this. Really appreciate it. And you guys have a great day.
Yeah. Yeah. Great day.
Thanks, everybody.
Yeah. Thank you. Thank you. Thank you very much. Bye bye.
Bye bye.
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 Bye.